We are ready to go. Let us go ahead and get ourselves started. We have many things we'd like to accomplish today. It's hard to believe we're actually like halfway through the whole quarter. And now the rush gets sets on in terms of like trying to pull all many different things together and kind of get them to add together with the goal of ultimately sort of having a project that shows how we're going to integrate together an awful lot of different systems and share it with each other. So, hopefully you're all making some progress in terms of the modeling of your projects, have your basic design concept moving from just sketching to actually having something that's in a modeling system so we can start working on really shaping some of the details of those things. I'm meeting with individuals on just how to model unusual forms and kind of specifically very challenging conditions, things. If you're stuck on something, you're just not quite sure how to get going, please let us know, and we'll schedule a special appointment and just kind of really look at your project and how the modeling tools will support that or how you can adapt them to go ahead and be a little better about that. Because a lot of times, a little kickstart can take you a very long ways in terms of just understanding. It's hard to get an unusual form that doesn't look like kind of perfectly vertical walls and straight surfaces to know where to get started sometimes. So take advantage of us to go through and do that, because it's actually a lot of fun to consult on your things. And we often kind of realize things together about the project. In terms of where we're going over the next couple of weeks, just so you have a rough outline to set your own expectations, what we're going to keep on doing is adding layers to your model. So we're going to talk some more about structural loads and how we would do some analysis of a model this week. And then moving to kind of mechanical systems, thinking about ventilation, just moving air through a space to meet the code requirements and the freshness requirements so that it's safe and comfortable, things like that. And then we'll talk about really how we add heating and cooling to that, to either chill the air as needed or to heat the air as needed to kind of keep it at a comfortable level. But we'll start with just the whole notion, and really on Thursday we'll do more of this, so mechanical systems and how you actually move air, what an air handler is, where you can place an air handler in a building, and how you figure out how big it needs to be to move the amount of air you need to. So using the tools outside that. Next week we're going to move into plumbing, continue with mechanical, we'll continue that next week, and then talk about plumbing systems both in terms of supplying water to the fixtures, but also start looking at the systems that we don't always think about, the sprinkler systems that are supplying the high pressure water to kind of take care of fire suppression, as well as how we model sort of more interesting plumbing systems, how we actually take and model either a gray water system where we're trying to reuse some of the water, store it, filter it, and kind of repurpose it to go ahead and handle flushing needs and kind of certain needs where we don't necessarily need potable fresh water, as well as how we would design like a water catchment system. So really how, given the roof that you have on your building, you figure out how much rainfall you could actually capture, size a tank to do that, and then really pipe that into the system to be used in conjunction with the city supplied water, the utility supplied water. Okay. We're going to then, the following week, shift into more looking at electrical systems. And electrical systems are actually pretty straightforward in the scheme of things. There are things we can do in terms of higher efficiency fixtures, putting lighting controls in, but there's sort of the basic notion of how you wire systems together and circuit them to go through and just supply all the plug nodes, the mechanical loads, and lighting loads, and really bring that back to power. So you just have sort of an appreciation of how an electrical system gets aggregated in the building. And finally, we'll go ahead and then the very last week, and what we're going to be doing all through Dead Week is just doing project sharing. And that's really, we won't have a final in the class. We're not even going to have a single review. It will really be more, we're going to be sharing projects that week, and some of you will do it on Tuesday, and some of you will do it on Thursday. In terms of just sharing a little about your project, and just really talking about the design principles, and how modeling work, and showing us what your model looks like, and just kind of talking about them together. So hopefully I hope you'll think of that as a fun experience as opposed to an incredibly high pressure experience. You do have to sort of get something ready for it and all that kind of stuff, but no one's going to be drilling you over the coals in terms of what's going on here. We're actually pretty soft as reviewers, so we try to be very supportive of what you're doing, and we'll try to bring that into there, because it's really, I would almost rather, I love it when people have, they really reach for the stars, they try to sort of explore some really interesting concept, even if you don't 100% realize it, and there's still some rough edges. The fact that there's rough edges and things that need additional analysis work, that's okay. With more time, we kind of keep on going. But Yeah. I'd rather you really try something that's very, very interesting and kind of moves your own thinking a little bit, as opposed to just being very mundane. So hopefully we'll make a very positive experience about that. Okay. Today, we are going to talk about structural analysis and how we finish applying loads to a building and then take it towards an analysis program to help give us some feedback about the sizing and are the members adequate? Are they going to carry the loads that we put on them? Do we need to make them bigger? Can we think about changing the spacing or decreasing the span? There's a lot of things we can do. And I think a lot of you are working through your structural systems. And for our buildings, we're going to we analyze a portion of the structure. You won't be doing the entire thing. Analyzing the entire structure of an unusual building. Again, it can take you almost a quarter to go through and do something like that. But just have a little bit of experience with taking apart of one of your floor plates and kind of running through the calcs and seeing how you can confirm that the sizes are appropriate. That's how we're just going to be approaching that. But before we do that, Raj actually suggested that we talk about some special architectural features that in particular some people are trying to implement. And really, how would you even go about trying something like that in a package like Revit? Because it's kind of interesting. We all talk about green roofs, but you don't really go and find green roof on the list of options. So let's think about how we could actually do some of those, because they're good issues. They're good. We'd like to start thinking creatively about how we can go through and kind of have interesting systems. So let me go ahead and we'll take a look at. Hang on. Turning off my notes, since not everyone wants to be reading my mail. Okay, very good. And we'll take a look at how we can go through and think about modeling a green roof. Let's talk about it together, because I think there's really, we can kind of come to some conclusions together. So I'm going to switch over to Revit right now and just kind of, get ourselves going. I'll just close all these things. Some of us are working on some interesting design concepts before class. Let me go ahead and start out here. I'll say we're going to get a new architectural project. And we'll start with this whole notion of a green roof. Okay, and I'll just make some basic walls as a starting point. Nothing too special. Just going to want to keep it really simple for us. The top of the wall is below the bottom of the wall. Okay. That's never a good thing. Wall. Level 1 up to level 2. Okay, that should be fine. Let's see if that'll work. What am I? You're going to have a rough day when you can't even get your basic walls done. Okay. Pause. Reflect. I choose the wall tool. I choose to go to that. It's going from level 1 up to level 2. That looks pretty good. Wall center line. That looks pretty good. I'm on that one. That looks pretty good. Doesn't look like they're showing. When Revit fusses with me too much, I close Revit. And I reopen Revit. So we'll see if we can get that again. Again, Revit. Starting with a clean slate. Let's give this a try. Okay. So something new architecturally. Some walls. Nice generic, that looks pretty good. Up to level 2, hopefully that's gonna look good. That's looking better. Okay, and on top of that I'm gonna go through and put a roof. And I'm not gonna worry about the structure for it right now. We're just gonna put a roof on there so we can sort of understand the concept of the roof. And I'll put some roof on that has a little bit of overhang on it. Again, it doesn't necessarily need it. Well, it would sort of depend on the side of the building. Okay. Let's start with this. As we're modeling a roof, green roofs, are green roofs flat or green roofs sloped? What can they be either? Any votes? Could be either. Yeah, often they're flat. They can be sloped. There's nothing else. Hopefully it's not going too awfully sloped because you have to kind of keep the planting material on it. But yeah, there's really no restriction. I'll make it flat right now, but it could really be just fine. In fact, there are some very interesting green roofs, like at the Cal Academy of Sciences. This is kind of this nice undulating green roof. It looks like a big hillside. So it's looking pretty good. So I'm going to go through and just put a roof on this thing. Take a look at it. This plain old flat roof here, he's looking kind of boring right now at only 12 inches thick. Let's think about the construction of a green roof. Yeah. There's sort of a structural layer, and then there's all this planting material that kind of comes across it, and drainage, and water, and there's a lot of different layers to it. And we can actually go through and model all that stuff. Like, for a green roof, do you have any sense of really what the structural layer might be to go through and support that? It could be steel with concrete on top. It could just be concrete. You want something that's going to be able to hold a fair amount of weight because actually, of all the different things you can put up on the roof, green roofs can actually be pretty heavy, and that water is a very heavy material. If the earth is absorbing an awful lot of water, that's one of the heaviest things you can do is just put like standing water on a roof. So, it's probably some pretty hefty material. So I'm going to make mine concrete for right now. It might be a steel deck with a thin concrete layer on it. But I'll put some concrete up there for right now. So I'll go through and choose concrete. Say super. Oh, maybe about 8 inches or something like that. Now, the key to green roofs is that you're going to have a bunch of different layers that are sort of working together. And yes? Yeah.
How good an idea is to put a green roof if it doesn't rain as much?
Oh, that still is very good. Green roofs can be used for capturing water. They can just be used just for thermal kind of blocking and stuff like that, just kind of make a nicer space in the landscape. So either way, it kind of depends. The water's really if you just want to catch the water or not. Anyway, yeah, green roofs are sort of fine and dry climates too. Okay. Although we have to maintain them. Often, one thing you want to do with your green roof is you don't just want to put plain old grass up there that you have to run a mower up on all the time. So it tends to be very natural, local, kind of sustainable materials that'll hopefully grow. In fact, when we talk about green walls, it's going to be the same sort of issue. You don't want to put a high maintenance surface up there because people aren't always so good about maintaining their lawns. So, we want to kind of keep it easy. So on top of this, we're probably going to go ahead and have some different layers of things. If you think about the section of a green roof, what tends to happen is you'll have the structural layer. You typically don't just have the earth, that wet earth sitting right on top of the structural layer. We tend to have some sort of layer that's drainage, a little bit of air space in there so that the water that percolates down can kind of go off and head off into other places. That might be sand and gravel, that might be some sort of a barrier that's keeping the earth and kind of keeping kind of clear space underneath it so you have a very clear channel for the water. But there are probably some other layers, and we just really need to kind of think about, even as you're thinking about building a green roof, like what system you're going to put in there. So for example, if I wanted to go through and put in some airspace, because I wanted to allow sort of some really clear space where if I was capturing the water, it would run off and I could, get to some sort of water catchment system, I might put an airspace in there, okay? And that could be like 3 inches thick or something like that. Then on top of that, I might have a layer of like sand or gravel, some sort of a substrate, and then there'd be some kind of hard layer. So let me kind of add another layer in here. Oh, the substrate might be some sort of, often it's these kind of funny plasticky, rubbery materials or something like that. I'll just make it the default roof right now. I'm not really sure what it's going to be just yet, but it's going to be relatively thin. Oh, like a ½ inch or something like that. Okay. Then on top of that, I'm going to go through and add, maybe like a sand and gravel layer. So we can go out here and see if we can find sand. There should be like site sand. If you can't find things in the upper part of the dialogue, we'll come on down and look in the bigger library to see if we can find it down in there. So let's see if we can find something that looks like site materials. What do I got in here? Let's try to see if I can do some searching for sand. Okay, I got sand. If you have something like this, which is sort of not in the project, but it's in the library, and you want to get it into your project, all you got to do is you either double click on it or click right here. Okay. And then that's my sand material. Okay, and I'll decide, oh, I want 3 inches of sand, something like that. Then on top of that, you need some earth. And the truth of green roofs is they tend not to be like 18 inches of really heavy earth. It tends to be really kind of thin. It's just enough to go ahead and support the planting material. So let's go ahead and we'll put in another finish layer here. Now, as I'm putting in the layers, just so you know that there is some sort of a sense of a hierarchy to this in terms of that number that's there has to do with around corners, how things will match with each other, and if things are overlapping, what will sort of come together the best. Things like finishes that have a 5, they'll try to match the hardest, and things that have a lower number, they're considered subordinate in terms of like the matching order. So things like gypboard, which need to wrap around the wall, they tend to have a very high number. Often like your structural layer, things that are in the inside have a very low number because they probably don't go wrapping around the outside of the finished layers. So it's kind of like an indication of how close you are to the outside, basically. So in here, what am I going to put in here? I'm going to put in some sort of earth. Grab that up. Oops. Earth is in there. Okay, so I don't know, maybe I have like 8 inches of earth, something like that. And if you want to, just for rendering purposes, you can even put some sort of a layer to represent the planting. Okay, and that's not a bad thing to do. So I'll call it, oh, let's go out there. I'm going to start with grass, which is again, oh, plant. That's much, much better. I don't really want grass, but I was going to sort of cheat it by doing that. And that might just be like an inch or something like that. But I basically built up this big assembly. You can see I've actually gotten it up to close to 2 feet. It's almost there. Notice though, interestingly, in the scheme of things, it has kind of an interesting sort of set of properties to it. Yeah, green roofs have this. They're good on thermal mass. They got a lot of mass up there. So if it's holding heat, it's going to radiate it slowly. It's like a big absorber, like a big sponge. It's going to radiate it. It's kind of a buffer. So they're really good on that. Notice actually for thermal resistance, they're really not very good. Just wet earth in particular actually conducts heat pretty well. It's not a really good resistor. So if this is the case, maybe somewhere along the line in here, I would like to go through and put in there some sort of, oh, maybe it's below the substrate or something like that. And I'll go ahead and put in there some sort of rigid insulation or something like that. That would actually probably increase the performance of the roof quite a bit. So I'll say rigid insulation, and oh, you know, maybe it's like 4 inches of that or something like that. So it got thicker, but the thermal resistance got a whole lot better. So this isn't so bad. That's actually getting close to a wall kind of construction. So most of our walls, light frame construction, are R19 now, R20. That's pretty good. Our roof is as good as our wall. So that's not so bad. Okay, so anyway, I've made this huge 2 foot 3 inch thick thing, and okay, cannot ascend for the core of the finish. So what I have to do is, so I'm gonna switch that. It's going 2 to 5. Okay, and I can put it in here. Now, so far so good. It doesn't look too awfully bad in terms of what's going on. If I go through and turn up the level of precision, again, you're not seeing very much difference in terms of how this all looks. If I shade it, you know, it's not looking very different in terms of actually seeing all those different layers. If I do go through now and put a section through this thing though, let's get up, cut a section, I'll say view. And I turn up the coarseness, you can actually see all those different layers. So this will actually point out something about green roofs that you have to stop to consider though, and that is as follows. I got all my different layers, they're looking pretty good. I got my concrete, my airspace, my insulation, I got some sand, I have some sort of material, that's all looking good. Things you have to consider about with green roofs are kind of the end condition. You have to worry about that. You know, 'cause you could try to berm it all down, but that doesn't tend to work out very well because, you know, dirt doesn't do a good job of staying where it's supposed to be. So what you may need to do with your green roof is actually go through and put some sort of a boundary on the outside of it. Cap it off with some sort of wall. So what I might do in a case like that is then I have my roof is go through and put some sort of a wall, some sort of structural wall. Maybe it's made of concrete, something like that. What I will do is I'm just going to go ahead and draw it right up against. It's only going to be a small wall. It's only going to be, like a 2'6" tall or something like that. It's going to be a fairly small little thing, but I'll go ahead and put it so that the interior is where I click. So it's going to put it on just the outside.
If you did put on the wall, like, what would happen? Like, would anything go wrong, or would it just look weird?
Oh, no, it's really, we just have an issue of trying to keep the dirt up there. So yeah, you could actually try to taper it down. And some people would do that. That's like, yeah, you could make it structurally stable so it does have some sort of cleaning in here to make sure that it doesn't just sort of wash away.
So in terms of, like, if you do, like, structural analysis or anything, does it change if you don't have the thing?
Well, from a structural standpoint, most programs would just consider that a mass and not really kind of think about the true properties of what it is. You know, even in here, you notice I got these different materials. Like this thing I just put in as a generic wall. Let me change its type, duplicate it, concrete 8 inches. Yeah, if I was being a little bit better, I might go ahead and make that the cast in place concrete too. Say okay. Still doesn't look like it's a whole thing. What you can do though is, let me see if I can actually get this to work. Well, actually, you know what I should do? Another way to do this, I could make something called a fascia, where a fascia would really wrap around the edge of the roof. It would be implicit that it's going to follow the roof. Doing it as a wall was kind of a little cheap, but it sort of, it worked. Let's see if what happens if I join those. If I join the wall and the roof, what happens is based on the material hierarchy, you join them together. Okay, so that's kind of good too, but again, you know, this isn't going to be all, it's not going to analyze kind of that little folding. We have to kind of do the force that's kind of pushing out on the outside, because there will be a little outside pushing out. Yeah. Structure is still going to consider that primarily just one big roof. Okay, so you can do roofs like this, and they actually, you know, that's not too bad. Other things you might want to think about with your green roof, though, is, you know, I got my fantastic green roof, and when I was thinking about my own design for the building, I thought, okay, I like the idea of a green roof as a part of it, so I like the idea so you have a terrace and people be out there, but you can also kind of see the green roof, or maybe get up on the green roof and lay down and enjoy the vegetation and stuff like that. Okay, so I kind of like that idea of sort of mixing it a little bit, some that's just normal roof and some green roof. But even within the green roof, you know, you think about, you know, do you want to have a skylight opening or some sort of penetration to kind of let the light come on down? And you can. I'm going to show you how something like that would work. So again, I think it's sort of a nice feature. So if I go up to level 2, if, for example, I would like to cut away some of that roof so I could have like a nice skylit atrium or something in the central little space. What I can do is something like this. I'll say, hey, let's go ahead, grab that roof. I'm going to edit its footprint. And it really starts with all this notion of cutting things away is just to go through, you know, do something like that. I don't want to make a pyramid out of that. So I'll turn that away. Okay, so now I have just a hole in my roof. So not too bad. If I put my hole in my roof there, I still do need to do, whether I'm going to do it with a fascia or a wall, I decap it on the inside, which again is not so bad. So what I'll do is come back over here, and I will add that little wall in there. Again, doing it to the finished face interior. So that's not so bad there. We'll finish that up. Oops. Again, if I make it concrete, I just did a tab there to get them all. Okay, so that's kind of a nice surface in there. Maybe I'll do a little join. Did I get it? Okay, sounds looking pretty good. Yeah. We would probably like to have some sort of covering over this thing, so you can think about this now in terms of what you'd like to do. Yeah, I could put just sort of a flat piece of glass right here. It's probably better not to have just a flat piece. Maybe it'd be better to go ahead and have something that kind of pokes up a little bit, like a little pyramid or something, or even sort of advertise it. For example, I might want to, let me tab and get those. Say, hey, not just 30 inches tall, but what if those were like 48 inches tall, not 48 feet? Hang on. Kind of poke it up a little, and then put something so you can sort of see where the skylight is. Let's put a skylight on that. So I'll say, come back over, zoom to fit. Oops, missed one. Okay, so different ways of putting a skylight on there. There are skylight objects. The skylight objects are cool. They're kind of like windows, and they cut things away. When you do a big opening like this, though, you tend to actually want to use something a little bit different. Let me kind of tell you about a really great type of roof that we haven't used, but it's called a sloped glazing roof. Take a look at that. So here's how sloped glazing works. You go to the roof choices, and so I'm going to make it at level 2. Actually, what I'm really going to do is make it level 2 plus 4 feet, because I want to sit it on top of that thing. And then we're going to go through and draw some sort of boundary. So I'll pick the walls. Oops. I'm going to turn off the overhang. So I don't really want that. It's drawing it down below at the true level of the bottom of the roof, but that's okay. We're going to fix that in a second. Okay, so we're going to say okay. Let's do that. So that's one way to do it. You know, it's that big old kind of rectangle. It's a roof. You know, it's kind of just made of some roofing material. It's actually our 12-inch thick roof. That's why it's looking so incredibly thick. That looks a little bit better. It's only 9 inches thick. So we could do something like that. Or if you prefer, if you make it sloped glazing, okay, you can make it more out of glass and decide, you know, do you want it to be a pyramid? Do you want it to kind of slope up from one side? You know, here at Y2E2, we actually have sort of a combination. We have glass sloping from one side, and we actually have glass walls coming up the other side to kind of make that little shed roof at the top. But that's all available to you. So for example, if you don't want it to be this way, you can say, no worries, let me edit the footprint. I'll just make the slope go on the different sides. And, well, actually, that's interesting. I could have, maybe that would be better, say that I want to take those walls and attach them to that roof. That wouldn't be so bad. Yes?
Let's say you don't have walls
Yes.
underneath, and you just want sort of like a huge skylight. Because I tried doing that, but then I couldn't attach.
There was nothing to attach, yeah?
Yeah, I didn't have anything to attach up to.
Yeah?
And the surrounding area was just another roof.
So, you know, could we add walls to it to get the, what would you like the closure to be around it?
Glass.
Like glass again? Oh, no worries. What we can do there even is, for something like this, so I kind of stretched it up and did something funky there. Let me do this. Can I split these vertically? I think I can. So I got wall. I want to keep that little bit of curb, but what I can do now with this upper wall is actually, I think what's happening now is it's missing. I need to kind of stretch this out a little bit further to get it to stretch on up. But it's, yeah, you can basically make them glass also in terms of what's going on. I think what's happening is I just have a little bit of a, that's coming to like the edge and that's sticking outside there, but we can go ahead and close it from the different sides like that. So, did that answer it? Or I know I sort of fluffed through that. But let me see if I can kind of, yeah, get you approximately there. It's basically doing something like that to kind of enclose it with glass. Is that sort of what you're after in terms of doing that? Yeah, so yeah, go ahead and use that glass, and then we'll figure out what the boundary is between the lower glass, for example. If that wants to be very low, and that one wants to come down to it. Yeah, super. You kind of do that and kind of do it on all sides. So the cool thing about doing this is actually, you're creating sort of an interesting kind of system for not only having the green roof, but also getting the light down in there. But let's talk about this. This is kind of a funny one. Christine actually had a question. We were talking about her roofs the other day. And it's kind of interesting about roofs like this. If you want good daylight all the time, okay, but you don't necessarily want direct sunlight. Let's think about different variations on this. So what's going to happen here? The sun's coming in. It's coming from the south side. Let's go ahead and turn that sun on. See if I can shift the sun over. It's a single day. It's the south side. It's going to be, like 2 o'clock in the afternoon. Sun's coming in. So what's actually happening inside here? Okay, in terms of the sunlight in the space. So with that big glass area here, it's all kind of coming on down. It's penetrating in there. You have a big space where you may or may not like the amount of light that you're getting in there. It's a little uncontrolled right now. So if you want to control that, what we can actually start doing is thinking about mixing up the materials. So instead of that being glazing, maybe that is even a solid surface. And instead you just have glass on the one side. Let's talk about the advantage of that, or why that's useful. So in this scenario, I have the glass just facing the north side. I have no glass facing the south side. Okay, so what does that give you? Okay, does daylight come from the north side? Yep. So daylight comes from every side of the building uniformly. So in terms of getting daylight in there, the north side is pretty good. Does sunlight come in from the north side? At least not in the northern hemisphere. Okay, so for a lot of spaces like artist studios and things like that, they actually put all these skylights facing the north, because what happens is they want the nice daylight, but they don't want the direct sunlight on your painting or bothering you as you're trying to work in that studio space. So you do, it creates sort of a nice ambiance for you there. As you look at this big old surface, this prime-looking surface facing the south, where the sun is going to be, does that suggest anything to you about an opportunity? Because it starts looking an awful like a great surface for some solar collection, if you want to do something like that too. So there's a reason why that's kind of a really nice roof shape. This whole sort of sawtoothy roof where you have the south side versus, that actually sort of works out pretty well from that standpoint. Okay. Let's reverse the scenario, because a lot of people will do this, and just to sort of understand the difference, we'll say, I want to have the slope defined this way. Okay, and I'll make that one glass instead. Little storefront action. See if I can stretch that up. Maybe I won't be able to stretch that up. Don't fight me. Talk to me about that roof. How are we doing for daylight? Still okay. How are we doing for direct sunlight? Maybe too much. I don't know. How are we doing for solar collection? It's really bad. This surface, it's on the north side. It's rarely, if ever, going to get any sun to it whatsoever. So it really does make a very big difference about how you do that. Okay.
So
Other.
would you say that it's almost always better to do it the other way, facing north?
If you're trying to get daylight, and actually, yes, in a lot of cases, and every building's a little different. It really depends on what you're trying to maximize. But just even something as simple of, if I put the little glass pyramid like the Louvre up there, then I'd have, daylight. I'd have a lot of sunlight. I could get some solar on one side, but just the shape can really totally affect, what your potential is for that. Actually, I'll give you one more thing about this funny roof, just to kind of complete the discussion. I like this. This stuff is actually kind of fun. So if we look at, okay, I got this little area there. Okay. Notice this little kind of thing that's happening on the side of the skylight. The skylight's kind of continuing to poke up. I can stretch that up. It's doing whatever it's doing. But I have these little walls, including this little section of wall. It's about 2'6" of wall right there. Okay, yeah. Let's think about what that's actually good for. Because it actually is. Okay, so here's the deal. If I have just a plain old flat surface and I put glass in it, what happens is as the sun rays come through, as the daylight comes through, it radiates directly down, okay, and sort of hits this much area. It's just going to hit the center, kind of what directly can be hit with the rays. Okay. What happens with these little surfaces, though, is they give you a little reflection surface. So the interesting thing then is, as the sunlight comes in, it not only radiates down, all the sun that would just sort of hit the roof actually hits the little white sidewall and bounces back. So it's weird, you actually capture more sun by putting a wall that's a reflecting surface in than just having it like be all by itself. So even for this little guy right here, it's gonna sound really goofy, but for this little chain of walls right here, I might even go through and do something where I lower them down a little bit, like that, so I get even more surface to go ahead and collect that. So watch this next time you're in a space that has a skylight on the roof. If the skylight's just in the sloping roof, this is a flat plane of glass, you get a certain amount, but watch what happens if there's like one of those little tunnels. It comes in there. So even in here, let's talk about this ever so briefly. I have the choice of a flat plane of glass. I have the choice of going ahead and putting the straight tunnel in. In this case, what happens is when the sunlight comes in, all the sun that's over here comes and does that. Yeah, that's going to go direct. This is going to bounce back. So, yeah, kind of get that. So it's actually to your advantage. So often it's better this way. Another thing to consider, though, that's kind of fun is, what happens when you do tunnels that do that? And that's sort of a compromise between. You still sort of get the reflective surface, but what is it? I think you actually get even better dispersion of the light, because everything's sort of relative to the incident angles. So, designing skylights in little sun tunnels is like, it's incredibly interesting. There's a lot of variation in there. So go ahead and play with that. Okay, that's kind of the green roof. How does that feel in terms of green roof? You got a sense of what to do with your green roof? Okay. Yes?
How
Yeah.
much weight should you consider a green roof to be bearing?
Okay, the worst case scenario would be if that thing got absolutely soaked with water. So, and that would happen if your drains got clogged and you had like 18 inches of whatever. You could actually have like, a foot of standing water or 18 inches of standing water. So do that times 62.4 pounds per square foot. So what is that? If it was 6 per square foot, and if it was 18 inches, then you could have, you'd be 90 pounds per square foot. Something like that. So the worst case would be, if it was just soaking in water. Earth is actually lighter than water. So
What about just like under normal circumstances?
Yeah.
Not like a disaster happens,
Yeah.
but under normal circumstances, like will Revit figure out about how much the dirt is and the plants are? And
No. What it'll do is we're going to have to, as good engineers, just plug in our assumption about what we think is reasonable. So maybe we want to assume 18 inches of standing water. But we'll figure that earth, when it's marginally wet, but not soppy, we'll make some assumption, not for the 100-year flood, but for something that we consider to be a reasonable engineering judgment. And actually, I should ask you, in any of your classes, have people ever given you a number for what to use for a green roof? Yeah. It's actually, we should do some looking on that in terms of what people actually do assume, because often you don't want to assume the absolute worst case, but there's probably what's considered to be a reasonably prudent engineering judgment. But really, Revit won't help you, although if we put in an earth and all the materials, it would calculate a weight per square foot. But I'm not sure if that actually gets transferred directly into the structure program or not. Thermal properties do. I'm not so sure about if the weight does enough. But in theory, you could, because everything's got a volume and a density. Although we didn't model the water. That's what we're sort of missing over here. Okay, that is the whole notion of a green roof. So play with green roofs, and don't, just because Revit doesn't have a green roof doesn't mean you can't model one. Just kind of think creatively how you do that. So let me give you just sort of another variation on the theme, and that is the green wall. Because green walls are pretty interesting too. Now let's think about green walls, because we have to sort of design it before we can model it. So as you think about a green wall, have you been to one, Lucy? Yeah. Have you been up to one of those green growing walls? How are they made? What do we know about green walls?
They have plants and like trellises.
Yeah. So one idea is we'll have a very light frame trellis. It'll be some grid. It's probably pretty light frame elements in here. Yeah, that's pretty good. And then the green vines grow up through it and stuff like that. And that's kind of okay. That's pretty easy in terms of what's going on. Well, we could do something like that. For a grid system like that, I'll tend to do that either as a surface that'll break up as a divided surface. And Julia and I were kind of talking about something like that a little while ago about breaking up a surface. We'll show you how to do that. Or you could even do that as a curtain system. Just really, because curtain systems sort of have this whole notion of these vertical elements, and you can sort of make light frame members to kind of do something like that. So that's one way. Another way to do green walls, though, if you have like a heavy frame construction, is people will do this, it's almost like they stack blocks. But then some of the blocks will have like these pockets in them. Okay. And in those blocks, you sort of plant stuff, and it kind of cascades over and kind of just starts dripping down the wall. And that's harder. I could make a block element and give it a pocket and all that type of stuff, but I don't know. This is probably the one I think about more often. It's kind of this gridded sort of system. So a lot of ways of doing green walls. Well, let's go for the light green wall. So for a light green wall, let's think about how we could do that. How big would you guesstimate you want all these little elements to be, to kind of be an effective sort of trellis? We can make them round, we can make them square, but how big do you think those things are? You're designing. An inch? 2 inches? Make them like 2-inch circles or 2-inch squares, whatever. Okay? It could be perfectly even, or we can sort of vary it a little bit. So, maybe they're 2-inch square this way, and maybe it's a rectangular over there. Okay? How about the spacing in here? What do you sort of have in mind for your spacing? To grow, every 6 inches, every 8 inches? I don't know. It's up to us. Yeah, let's say we'll do 8 inches. Okay. Again, we're just making it up as we go. And that's, you can really design them to be however you want them to be. So, we're going to create some sort of system like this that's going to be fabricated for us, and here's how we could do it. Okay, it's all going to start in this funky building. We're just going to go through and add some wall to it. So let's add the wall, just kind of out front. So I'll put some wall in here, and I'll just make it sort of a plain old wall for right now. Looks like I'm up on level 2, which is never a good thing. Well, it's not a bad thing, but kind of an odd thing. I'll just make it unconnected, 20 or 30 feet tall, so you can see it. Okay, we now want to go through and make that some sort of gridded system like this. So here's what we're going to do. We're going to take this thing and say, as a starting point, let me just change it over to a storefront, which is close, but we're going to work with it. Okay. Now we're going to adjust this thing, and we're going to say, okay, let's edit its type. And I'm going to duplicate this. And we're going to call this just my green wall trellis instead. So with that, I have Facebook pending notifications. I thought I turned that off. Okay, let's take a look at the panel itself. And I tried to do this once for you before, and see if I get it right this time. I think it's there where I say none. It won't be, but that's where I'm going to guess. I'm going to give a spacing of, about every 8 inches by every 8 inches. And now it's just an issue of kind of whatever these mullions are, whatever these cross sections are right now. Right now it's 2.5 by 5, and let's just test that. You know, you'll find that I often test things because I often guess wrong, and I sort of get there incrementally. We'll let it do a little generating. It's doing a little flashing because it's generating a whole lot and it's kind of stealing graphics resources. So I'm going to try not to panic as we're waiting for that to do something. It's doing a little regenerating because there's actually a lot of little pieces. It looks, oh, there it is. So gray. Okay. Looking a little chunky right now, but I think it basically has the idea of what we're doing. Well, then let's throw some glass in there. Turn right off. Yep. No, so I didn't get rid of the glass, so Raj, you're going to remember how I have to get rid of that glass in just a second, because that's why I tried to do it last time, and it just wasn't quite there. It says curtain panel none. I think it has to be system panel open, glaze, solid, empty system panel. Why that is? It's really bad when you know something wrong, and you realize you're doing it wrong, but you don't remember what the right way is. It's that. I have many things that are like that. Okay, so these grids, they're looking pretty chunky in terms of what's going on. So how about this? Instead of kind of sticking to these 2.5 by 5s, I'm going to make them real small, like these 1-inch squares. We can go through and make other sizes, just really whatever we want in there. Maybe I'll make the other ones these 2.5-inch circles, just to kind of vary it up a little bit. But these are all just profiles, and we can adjust the profiles to really be whatever we want. For example, probably it would be better here even to let the intermediate ones be these 1-inch squares, but the outside edges be these fatter ones. You know, just something, the borders to be a little chunkier, because that's actually usually the way it is. And again, don't ask me what border 1 versus border 2 is. I don't remember if it's left and right and top and bottom, or right and left and bottom and top. But that's basically the idea. So we'll cross this over, and it'll be the green wall trellis, and hopefully it'll look pretty good. The good news about our green wall trellis is our green wall trellis will cast shadows accurately. So that's good. It'll be taken into account as a shading surface. It'll be understood. Okay. What it's not so good on is actually you kind of want to put the plant on there in terms of doing that. And in terms of modeling it, that's actually kind of difficult. From a rendering standpoint, we could put a material on there that's transparent, that looks like some sort of lazy... it's still generating. I'm watching it. We could put some sort of a lacy kind of ivy-like something or other, and put it in there from a rendering standpoint. From a modeling standpoint, it's pretty difficult to do that. And even then, we want to start thinking about this whole notion of, well, even this is a pretty good example. I got my big old thing over here. It's all ready to start casting shadows and stuff like that. The problem is, though, actually, you know, that thing's kind of, I call it resource intensive. A lot of pieces over there. It takes a lot of work every time for us to draw that. So every time I do one of these things where I orbit or whatever, it could take a fair amount of time to do the recalc and the redraw. So especially on a gigantic building, you may or may not want to have those things visible. What I would recommend doing that, just so you sort of have that ability to kind of work with it though, is do this. Go ahead and duplicate a view. Super. And what I'm going to do is rename one 3D no green wall. And just in one of those views, just hide the green wall. If I can get to it, there's so many pieces. It's actually kind of really intensive. Okay, like that. And I could hide that a number of ways. Hide in the view. Just sort of understand whether you want to show it or you don't show it. Because once you've figured out that it's there, we can put a reasonable approximation there without the detail and just really speed up your graphics operations so that, when I need to do a lot of mass movement, I'll be in this one. When I really want to see what it looks like, I'll come back to this one. So, don't be afraid to turn off things just to kind of speed up, because especially things like this, when people do these very articulated building facades, it gets to be very resource heavy. Okay, so that's how I'd probably approach the whole notion of doing that if I was doing it more like sort of a grid. Oh, I wanted to do one other way just to kind of show you. And then I'll finish up this. And that is this whole notion of, like a panel system. And it's almost kind of like, Julia, what we were talking about in terms of dividing up a system. And let me kind of show you how you do it. If you want some sort of grid that's a little bit interesting and unusual, what you can do is something like this. I'm going to draw these thin little reference lines. I'll call that one curve A. I'm going to call this one curve B. And again, these are just sort of lines that are reference planes that I'm going to be able to draw some profiles to dictate a surface. So once I go through and do this, I can go through and create a surface. And I'm going to make something that's a little bit curvy. We could have done this with a flat surface just as well. But what I'm going to do is as follows. I'm going to create a mass. And I'll go over to 3D and make this. So don't worry if this seems a little esoteric and you're not going to use it, because you don't need to. It's just sort of available for people who might want to. We will do this. We will say that we want to go through and draw some sort of like line or a profile. Let me do it just a line for now. I'll go through and put that on plane A. So I'm going to draw some sort of line. I could draw this vertical, but I'm going to draw it as a slight angle. Okay. I am then going to go and draw another line over here on plane B. And maybe that one will go straight, or it'll be a little bit different. Okay. What I'm going to do is take those two different guys and actually just bring them together. I'm going to do what's called lofting together, just really make a surface. So that's a pretty boring surface. That actually does have some curvature to it. But once I have a surface, what you can do is this. You can divide the surface up into kind of an XY grid. And if you have an unusual pattern you want to apply to it, like for example a honeycomb or an octagon or a triangular surface or something like that, you can choose one of these patterns that they have out here. So for example, if you wanted like a nice triangular system, we could put that on there. And then actually sort of make a panelized system out of that. So, I can load in some panels, some triangular panels, and there's a lot of people who design these panels, and we could do some that are sort of more like a checkerboard surface. That have specific sort of profiles and characteristics to them. So I could say, great, I want to go through and put something like that in there. And make something interesting like that. And again, that's kind of a relatively mundane one, but that could go curving up and just kind of follow the entire profile of the building. I can make some really interesting sunshade. For example, that one's not that different. If you've ever been to Singapore, there's this place called the Esplanade. It's a kind of glass enclosed concert center, but it has like these funny shades all over the outside of it that kind of help block out the sunshine. So a lot of ways to do that. Okay, so questions about that, or does that feel pretty good in terms of what you need to do there? Excellent. Then let us adjourn with all that and shift our attention to the structural side of things and just go through a really simple example.